Hello everyone, welcome to the video. Today we are going to solve the LeetCode problem number 3769, which is a short integer by binary reflection. So let's read this question. Before reading this question, this question was came into the LeetCode contest 749 and it's a first question. So this is a easy mark question, but it's a easy question, but here are some tricks that makes a little bit difficult this question. Okay, so let me read this question and understand what they are trying to say that. So the question described as you are given an integer array nums. Okay, the binary reflection of a positive integer is defined as number obtained by reversing the order of its binary digits, okay, ignoring all leading zeros and interpreting the resulting binary number as a decimal. Okay, so let me show you the example so you can better understand this. So we have a nums, which is an array of integers. Okay, you can clearly see that, and what we have to do is we convert each and every number into a binary number. Here 3 becomes 116 become 110, 5 become 101, and similar to 8 become 1000. Okay, then we have to reverse this binary number, like 11 become 11, 110 became 011, and 101 became 01, because if you reverse 101 it's a 101. Then 1000 become 0001. Okay, so what we have to do is uh, let me put all this number. Then again, after reversing this binary number, we have to convert this into a decimal number. Like again 11 become the 3, 011 become again 3, because we have ignored this 0. We only put this 1 leading 0. So no matter how many zeros in front, we ignore all the zeros. Okay, we only put these digits. Then 101, then 0001, again we ignore all these 30, only put this 1. Okay, so let me put this in an array. So we got 3, okay, sorry, so we got 3, 3, 5 and 1. Okay, so what we have to doing is we have to sort this array. Okay, we have to sort this array in a ascending order. So whatever the sorting array is, it's become 1, 3, 3 and 5. Okay, 1, 3, 3 and 5. And after the sorting this array, we have to return the actual array. That means, let me show you here in the example. What are the first number is 1. Here is a 1. Okay, you can clearly see here is a 1. And what is this 1 representing to? This 8 number. This 8 representing by 1. So we have to create an array and put this 1 as 8. Okay, then comes to the next part. Here we have a 2, 3. Oh, here is the main critical role. Okay, here is the main critical problem, which actually makes this easy problem a little bit difficult. Okay, so this is a 3, this is a 3. Okay, if you look after here, we have 2, 3. Okay, but one is pointing to this 3 and one is pointing to 3. So how do we calculate this thing? How we sort these 2, 3 and what we put here? Okay, what we put here. So first we try to sort by this number 1, 5, 3, 3. Okay, you can clearly see if both the number is same, you can see both the number is same, then we try to sort according to their pointer number. Okay, origin number. Like here you can clearly see this is a 3, then this is a 3, both are same. How you sort this number? We're gonna sort according to this number. Okay, 3 and 6. So 3 is smaller, 6 is smaller, so 3, 3 first come first. Okay, so 3 is a smaller number, so we put 3, then this 3 mark pointing to the 6. Okay, after that we use the 5. Okay, so what is 5 pointing to? 5 pointing to again 5. Okay, so we put 5. So this is our actual answer. We have to return this thing. Okay, looks similar. Like here is the catch, here is the problem. What if you have both numbers are same? Oh, first of all, you think we can use the hash map easily. Okay, we can easily use the hash map. So let's try with the hash map. Is this possible or not with the help of hash map? Okay, so what we're gonna do, let's erase all of this and let's try with hash map. Okay, uh, let's suppose this is our hash map. This is our hash map. Okay, here we have the key and here we have the values. Okay, so first is 3, so we put 3, and what is the value? The original value is also a 3. Then we have again 3. Okay, but we already have 3 in this hash map. So what we're going to do is we're going to put this, we're going to erase this value and put it 6. I'm actually iterating. Actually, I'm dry on this. What happened if we use the hash map? Okay, because lots of people think we can use the hash map here and we can get all the original value of these values. Okay, because it looks like this is our key. We have mapped this value as a value. Okay, and we after sorting this, we must put all the key values and we get the answer. But we didn't get how I can show you here. Okay, so after that, so we put 2, 3. Then again we 5. Let's put 5. What is the value of 5? Is 5. Okay, is also 5. Then we have a 1. It's representing by 8. 1 and representing by 8. Okay, so we have this number. Let's sort this number. Okay, let's sort this number. So what we have, we get 1, 3, 3, 5. Okay, we get what we get is we get 1335, 1335. Then we replace all the values, all these values by their original values, and we store that original value in this hash map. Okay, so let's put their original value. So in a hash map, if you look, one is actually representing 8. Okay, then what you're going to do is we're going to put 8 here. Okay, then 3. Okay, 3 representing 6. Okay, we put the 6 again, 3, it's a 6, and this 5 is representing by 5. Okay, so we got this answer. Okay, we got this array, but this is not our answer. This is a wrong answer, because we have a 2 3, but those original value are different here. This 3 pointing to this 3, and this 3 pointing to this 6 value. Okay, so we have to use something different here, so we can put both the values. Okay, so what we're going to use here is we're going to use here a 2D array. Okay, this 2D array help us to store the values. Okay, so let me show you how we're going to do this here. So we know we have a 2 value. The first one is our original value, then second one is our modified value. Okay, so what we're going to do is we create a 2D array with the length of n. Okay, and n is to 2, we create the array of n is to 2. So what we're going to do is let's put it here and let's create this. Okay, so we have a 2 value. What the value of n? Here we have a 4 values. Okay, so 1 2 3 and 4. Suppose this is a 2D array. Okay, 2D array. This is our 0th one, this is our first one. Okay, in the 0th one, what we're going to store is our reverse value. Okay, reverse value. So what are the reverse value? That array 3, and in a second second row, what you're going to store, this second column, what you're going to store is our original value, which is representing to 3. Okay, then again 3, what this point to the 6. Okay, then again what 5, this represent to the 5 also. Then this one represent to the 8. Okay, so what we're going to do is again we go to our first thing, put all the value that we have this value, and sort this value. So what we're going to get this 1 3 3 and 5. Okay, here is the catch. We earlier we only sort on these values. Okay, 1 3 3 5. Okay, we sort this value, but I already told you earlier that we have two similar value 3 and 3, but those 3 but these 2 3 pointing to different values, like first one pointing to 3 and the second one pointing to the 6. So if those values are same, then we sort according to this number, like 3 and 6. We have 2 3, we first take 3, then take 6. Okay, so what we're going to do, we're going to sort this array, this 2D array. Okay, we're going to sort this 2D array. Yeah, this 2D array. Okay, so first whenever we can clearly see these 3 and these 3 are the same. When you are trying to sort these, both are 3 are same. Then if we both are same, then we look at to the second values, their second values. What, then this 3 and then this is 6. Okay, then we sort according to this. Okay, so what we're going to do is first try to sort this one. Okay, and actually we put those values. Okay, first if we try to sort, first what we get 1. Okay, what are the smallest value at this column? What are the shortest value in this column? What is the smallest value? Is 1. So what we are going to put is we're going to put value of 1. What is the value of 1? 8. So we're going to put 8 here. Okay, then jump to the second largest number. We have 2 3, both are similar. So which one we take? We're going to choose from these values. Okay, so this is a 3, this is a 6. This 3 is the smallest, so we took this 3 here. Okay, this is a 3. Then this 6 is then 6 is bigger than 6. Then what are our remaining value? Is 5. So we put value of 5 is 5. Then we got the answer. So here you can see why we are not using here hash map, and instead of that we are using a 2D array that help us to sort our array and give the correct answer. So let's bring to the coding part, and which is very easy. I am using Java. You can code according to your language. I hope you understand. If you don't understand any point, please do let me know in the comment section. Okay, so first we're creating the n, which is the length of nums. Okay, and we are creating a result where we store our original result value. And again here we can create the array, create n is to 2. Why? This is our n value, the length of this array, the number of row we representing by n, and we only need 2 columns. First column we put our reversed value, and the second column we put our original value. Okay, and later we're going to sort this according to their number. Okay, then we start iterating. Okay, from 0 to less than n. So what you're going to do is first we need to convert those number. Okay, so we put in a num variable, and what we have to, what we're going to do is we have to convert this decimal number into a binary number. Okay, so this is our, what we're going to do is integer to binary string. Okay, so this method we use in Java. This method return a string value. Okay, so what this going to return is, this going to return in a string. Okay, this going to return, suppose we have a 1 1, so it's written in a string value. Okay, written in a string format. Okay, After that, what we have to do, we have to reverse this binary number. So what we're going to do is, we have a string. So what we're going to do is, we create a new string builder and pass that this string, okay, this binary string, we pass it. So we create a string builder. Why we're going to create this? Because we have a method in a string builder called reverse. So we can easily call this method and reverse that binary number. So what we're going to, we get this string 11, we convert this string into a string builder. I'm only talking about here Java, okay. And in a string builder, we have a method called reverse, okay. And this method reverse this string to 11 become 11, okay. And this after that, we after converting this in is reverse this, we return the string value, okay. So we have a string value of the reverse binary number, okay. Then we have to convert this into a integer value, and also we have to convert this into a decimal value also. So what we're gonna do, we have a method integer dot parseInt. we're gonna convert this into a binary number, okay. And put this I is equal I, we put this number, I mean the reverse number, in a first column, and the original number into the second column, okay. After that, we sort the array. I already told you about sorting method. We sort first, we sort by this first row, first column. If both number are same, we try to sort according to the second column, okay. So similarly, we're trying to this, we're trying to sort with our first column. If both are not if our column are not similar, then we sort this. If you are similar, we are sorting to the second column. And after that, we getting all the number, we put all the value to the result of I similarly, and just return the result. I hope you understand. So that's it from this video.